Hello, everyone, and welcome. Thank you for joining us today. We appreciate you taking the time out of your busy day to join today's webinar. I'm Naomi Langston, Vertical Marketing Manager here at TigerGraph, and I'll be your moderator today. In today's industry webinar series, we will discuss improving cyber threat detection with machine learning, visualization, and graph analytics. And we hope you find it to be informative and interesting. I am delighted to introduce David Braun. As a senior solutions architect, David joined TigerGraph in 2021, bringing more than 35 years of global security, governance, compliance, and auditing experience. Having worked at companies like Fidelis, Smarsh, Varonis, SecureAuth, and Calibra, David brings a diverse background of technology to our TigerGraph team. David also has taught at the University of Maryland and Central Texas College and has worked in both consulting and the corporate arena during his career. I'm proud to say that David is a 14-year veteran of the U.S. Army Singles Corps and is based in Chicago, my hometown. Outside of work, David spent time with his wife and 4 kids and 2 grandsons. Welcome, David.
Thank you very much.
Before we get started, a few housekeeping items. Your phones are muted, but don't take that as a sign that we don't want to hear from you. In fact, it's quite the opposite. We would like to keep this event as interactive as possible. Please submit your questions using the QR tab, and we'll do our best to kind of answer them on air. If not, we'll follow up with an email. And just a reminder, this webinar is being recorded and will be uploaded to our website just about 3 hours. And as a reminder, we'll also send you an email link to this recording. Welcome, David. Let's get started.
Thank you very much. So first of all, folks, I want to touch a little bit on a subject that all of you, I'm sure, understand, and that is related to cybersecurity and the number of breaches that are happening out there today in the business world. A recent Ponemon Institute report gave us some really astounding information here. If you look at this from August of 2019 through April of 2020, they were able to review a total of 524 identified and documented breaches. That means that these are people that have willingly let someone know that they were breached. Obviously, I'm sure there were more than this number out there, but these are the 524 that were reviewed. The most important thing on this slide, I won't go through all of the detail. There's a lot of information here, and as Naomi mentioned, it will be available for you as well. But if you look on the bottom left-hand side, the average breach, the average time to detect and contain those breaches is about 280 days. That means a bad actor is in your network, messing with your data, messing with your confidential information, your intellectual property, for up to 280 days. If it's a malicious breach, they found that it's almost 315 days before it can be detected and contained. Now, when you think about it, 54% of all organizations required remote work during COVID-19. 76% of those companies said that the remote work would increase time to identify those breaches. It's already at 280 days. Having all the work from home employees makes it more difficult. And they're saying that 70% of those companies identified or noticed that the cost of the data breaches went up because of the work from home employees. So when we think about it from a cybersecurity perspective, what does it really cost you to do this? Now, according to the Ponemon Institute, it's about $3.86 million for a standard breach globally. In the United States, it's about $8.64 million. That's a significant amount of money for any organization to have to incur because a bad actor decided to attack you. The most important thing is that it's not just enterprise organizations being breached. Mid-sized organizations experienced breaches and saw an increase in cost and number of breaches in 2020. Ransomware in and of itself has proven to be more expensive than any other normal breach out there. So you have to think like an attacker. An attacker thinks in graphs. When a bad actor enters your network from anywhere, they're immediately looking for something called breadcrumbs or metadata. What they're trying to identify is the information that shows them where the interesting information exists inside of your network. Following the breadcrumbs, the bad actor has easy access to identify all the different things inside of your infrastructure that may be important, that may be sensitive information. By continuing to look at the logs that exist on those systems, they can follow it to those interesting or more important servers, like your email server, your data systems, whatever happens to be out there. So you want to use something called the CIA, or the confidentiality, integrity, and availability triad, which is important. This model is designed to help handle policies for information security within an organization. So let's think about how Graph can help you. First of all, let's talk a little bit about where databases have come from. We're all aware of the standard relational databases, the Microsoft SQLs, the Oracles, the MySQLs. Those are your standard relational databases. They have very rigid schemas. They're not great on performance with deep analytics. And then we move to version 2 or iteration 2 of databases. We got our key value databases, our NoSQL databases, and that became more of a highly fluid schema or potentially no schema. They had still poor performance on deep analytics, but they had really good performance on simple transactions. The problem is that when you start doing analysis for cybersecurity, you need to be able to go deep. You need to be able to go 3, 4, 5, 10 layers deep to understand exactly where a threat may be coming from. With the iteration of graph databases, version 3 of databases, you're now finding that it has a flexible schema, high performance on complex and simple transactions, as well as high performance for deep analytics. So you've got the ability to really see the evolution of those databases providing better analytics, the extensible schemas that ensure high performance with deep link analytical reviews, and then it improves the performance of all of your transactions. So how does TigerGraph fit into this, and how do we really help? Well, first of all, we do it through something called connected data. We allow you to feed the data in from all the different systems that exist out there. We allow the internal and external data sets and pipelines with distributed information pushed into a single graph database that can hold up to terabytes or even petabytes of data and allow you to analyze it in sub-second response times. We allow you to look at the resource information, the server information, user information, organizational information. We bring all of that together and provide you the ability to answer these different use cases. So when you think about what you can really get out of something like TigerGraph, you can do anything according to this, such as insider threat detection. You can do impact analysis. You can start looking for financial fraud. You can start looking for trade surveillance and understanding what are people doing and how are they trading? Are they fitting within the regulatory compliance requirements that are set for your organization? We allow your cyber warriors to really focus on those real threats. The number one problem that a lot of organizations face is you have so many tools that a lot of the information being fed to you starts causing something called alert fatigue. The excessive logs, the manual analysis that's necessary out there, you see it with all these different types of endpoint systems, network systems, email systems, and so on. Now, the first answer that came out in the market was a SIEM. Push all those alerts, all that notification into a SIEM. The problem with most of the SIEM products that exist today is that the analytics are very high level. They're not at the level of what a graph database can provide for you. So by using something called multi-graph from TigerGraph, we have one master database. We're able to bring integration via API with your tools that exist today. We're not asking you to replace anything. We're saying keep your SIEMs, keep all of your existing tools that you have. But one of the problems that you face is, how do I train my engineers, all of my SOC engineers, all of my NOC engineers, all my security engineers? How do I train them on all these myriad of different tools that exist? It's difficult. So what you want to try and do is get an analytical tool that can bring all of this together And then once you have real alerts, respond to them. You do that through your SOAR. So what we're going to provide for you is the ability to take data feeds from all these different products, push it into TigerGraph, do deep link analysis of everything that's going on, and then provide a push of those alerts based on your configuration and your rules that you build out inside of our solution. You're going to push that over to the SOAR to do that response. So when we think about cybersecurity analytics, we have things like alert fatigue. We have breach identification. You have lateral movement. Now, keep in mind, anybody that tells you I can prevent a breach is not being honest with you. There's too many things happening out there. There's too many organizations that are proving that regardless of the level of security and maturity of your security stack that you may have, they're going to get in. Those bad actors are going to get into your network if they want in. The idea is to identify that breach as early in the kill chain process as possible. When I talk about a kill chain, what am I talking about? The MITRE Attack Framework identifies threats in a kill chain from initial access to execution, persistence, and so on, all the way down to exfiltration and impact. If you allow an attack to get down to exfiltration, you're in trouble. You're going to lose data. You're going to have a published breach. You're going to have financial loss. There's no question. What we're going to help you do is through the graph analysis, we're going to identify those anomalies, the patterns of activity, the relationships, the movement of data, your user interactions that are not normal actions. And with that, through the early detection capabilities of the MITRE Attack Framework and what we can do with Graph, we're going to be able to help you identify the suspect activity and allow you to identify those threats and respond to them earlier in this process. Now, when you think about graph algorithms, this is really where the threat intelligence comes in. We can do everything from our Deeplink analytics that I mentioned. We can do relational commonality. We can do hub and community detection. We can do geospatial graph analysis. So we have the ability to identify where things are, how things are communicating, what relationships exist. Given two entities, follow their relationship and find a commonality in them. Looking for the most influential members of a group to see, is that person doing something that they don't normally do? They're moving data. When you think about when someone leaves an organization, what do they typically do? Well, they're going to download data. They're going to get a copy of documents they've created, or they're going to get copies of customer lists, things that you really don't want them to do. So this is going to help you not only from outside threats, but also from insider threats. We're going to help you identify where there's potential issues that may be concerning for you. So what this chart represents is a logical organization of the 7 key data science capabilities powered by a native parallel graph. And that's what we are. We are a native parallel graph. The in-database machine learning and the explainable AI that we provide to you, the query and pattern matching that we offer, allow you to detect anomalies. Everything from flooding detections to footprinting detections. With Graph, you have the ability to understand anomalies by identifying each of these activities quickly. We also identify footprinting detections with requests of a specific IP address, for instance, and the user ID, which will identify where the particular action is coming from. Identifying the original egress point of a threat, or identifying the original start point of a threat, is important, because that's going to help you truly eradicate that particular bad actor from your environment across the board. Detecting specific user behavior patterns allow you to really get into the details. So let's think about this first one on the top. We have a user that had a mobile event. They added a mobile disk to their system. When they did that, it creates an anomaly. It creates an event inside the computer that is not something that you're going to want them to be doing. Then we see file move events with restricted data. They're going out and they're accessing data that they really shouldn't be moving from its location. And that ends up on that mobile disk event, and that mobile disk is then removed from the computer. Okay, that's an anomaly. That's something that shouldn't be happening on a regular basis. Maybe it's okay, maybe it's not. But by identifying this threat, sending that alert off to you, you can choose how you want to respond using your SOAR, using your other existing security stack tools. We give you the ability to see file reads, file touches, whether it's a delete, it's a read, it's a move, whatever those file events are. We allow you to really start getting into the details and understand when someone's trying to bypass a firewall. We can trace the source of your different alerts. So if there's a file corruption alert, and then we see a file read and a file write, we can see all that activity and trace it backwards to identify where did it come from, what IP was used, what system was used, what user was involved. It helps you identify the threats and respond to them quickly. Feature extraction will show you the shortest paths involving blacklisted user IPs or user accounts within your environment. Why is this important? Well, if you have a user that is not blacklisted, it's a normal everyday user, and suddenly that user is interacting with blacklisted users or blacklisted IP addresses, now we have a problem. So we can help you identify something called K nearest neighbor. Basically, what we're doing is we're telling you how many hops from that particular user does it take to get to that blacklisted IP, that blacklisted user account, that blacklisted system, so that we can identify those sequences of user behavior to help you identify threats and identify potential major issues inside your network. Using Deeplink Analytics, we allow you to follow potential threats and ensure that we can alert on potential anomalies earlier. So let's say we have a user. That user in the chain of activity, we're seeing that he works for a specific department, he reports to a specific individual or a group, and then he serves as an admin through connected IDs. From there, we can see what could be potentially privilege escalation. So escalating the privileges of a user ID or a system to give it administrative access to be able to go in and start services. They can start microservices inside of your systems that would allow them to exfiltrate data. And we notice that we see they're starting to try and push output or data out to external systems. It may be to a URL, it may be to an online storage environment, it could be to a private email address, whatever it is, we're going to see that activity as it's starting. So we're able to quickly help you identify the anomalies, and using, as I mentioned before, that CIA triad, confidentiality, integrity, and availability, that model helps us define with the collection of rules, and it limits the access to information for people that shouldn't have it by also identifying who should have it. We help you in that identification through our analytics and through our information. And we can send out alerts when we see things that are happening that really should not be happening. Now, the most important thing, there are many graph tools out there. The graph databases that exist, we are the only true MPP-based multi-graph tool. We give you the ability to create multiple graphs inside of our environment off a single data set. By doing this, we can allow you to share and collaborate between groups, between different types of data. We can integrate, we can link it with insights, we can add productivity information to it, and it gives you the ability to really collaborate in a way that you weren't able to do before.
Hey, David, sorry to interrupt, but we have a question. We have a quick question about baselines. Can baselines be set? Does it store the policies?
Baselines can be set through identification and through policies or rules that you're building out inside of the environment to say what is normal versus what is abnormal. From there, our in-database machine learning will help you improve on those baselines. Okay, so
Thank you for that.
absolutely. So the next thing is when you start looking at the real-time response, because we are a shared database and we give you the capability to have all of your data in one location, when we update the data, when we add new information coming in from other sources or whatever, as that data is being fed in, we don't have to rebuild our graph from scratch. It's just updating as it goes along. So once you build the schema, once you put the data mapping together, it will start updating on a regular basis. We also provide you fine-grained security. That security allows you to ensure that the right people have access to the right data sets without having access to things that they really truly don't need. Now, before we get into the demo, a couple of things I want to make sure that we touch on so you understand TigerGraph with our product overview. We are a native parallel and distributed graph database with an MPP, massively parallel processing architecture. The scalability, we have the ability to not only scale up, but we can scale out, adding nodes to your cluster to allow you to add additional data, going from gigabytes to terabytes to petabytes of data. We can scale with you as you need to. The performance, the analytic performance, as well as the machine learning performance combined with our insert performance, we have some of the best performance out there, over 300 times the speed of most other products out there today. The enterprise features, we have delivery modes that allow you to really connect in. We've got high availability. We have API integration with REST-based APIs that allow you to connect into pretty much anything that you need to connect into. We provide you something called G-SQL. This is a proprietary SQL language. It's a query language that we've built, and it's SQL-like. It's not a standard SQL query language. It is different, but it's easy to learn. If you understand the basics of SQL from Oracle and from Microsoft SQL, you'll be able to pick up G-SQL very easily. But it's a high-performance query language that is Turing complete. We also have Deeplink Analytics. We allow you to traverse the graph in parallel, filter, and do graph computations up to 12 or more hops in depth inside your production environment with literally terabytes and petabytes of data. The graph algorithms library that we provide you is an open source library available on GitHub, but we do have the flexibility and the rapid time to value for all of our algorithms. They allow you to grow your environment, to really tune your environment to meet the needs that you have quickly. The multi-graph service is a multi-tenancy with true RBAC permissioning and control. So for anybody that doesn't know that term, role-based access control, it's back to the old world of mainframes is where RBAC started, but it's a tried and true performance enhancing access control that ensures that only the right people have access to the right levels of data or the right levels of activity within the system. We also provide you a built-in visualization tool called Graph Studio. When we jump into the demo here in a couple of minutes, we'll show you that, but it's a comprehensive visual SDK from graph design all the way to deployment. And then we also work with partners to allow you to build even more extensive front ends if that's something that's important for you. The advanced data compression technology allows approximately 50% compression on all of the data that we're bringing in, but yet giving us the same speed and response time that we had before it was compressed. The machine learning features generate deep link multi-hop graph features in real time for massive data sets. We also are ACID compliant. So you do have both OLTP and OLAP on a single platform that's very cost effective. All right, so from there, we're going to jump into the demo itself. So as you can see here, Naomi, just confirmed for me, you can see the Graph Studio.
Yes, we can. Yes, David, we can see it fine. Yes.
Perfect. So Graph Studio, as I mentioned, is everything from implementation, design, schema setup, all the way out to delivery. So if you'll notice here in Graph Studio, this is the developer edition. So you're able to see everything that you need to be able to see, from designing your schema and some of the terminology used by TigerGraph. We have something called vertices, which are your nodes that exist, your project, your company, your person inside of this particular graph. And then you have edges. Those edges give you the capability to really dig in and see the different things that are going on out there. So I'm going to jump over here into our cybersecurity solution. So through tgcloud.io, we give you different levels of systems that are available for you to start digging in. You can build graphs, you can build information based on different things that you need to see. And then as you're designing your schema, as I mentioned before, you see all of your nodes or your vertices, and then the connectors or the edges. Each of these can have attributes in them. So you can see here we have service name, service type, and the different edges. They can also have, if you decide to put it in there, you can have all of the information that you feel is relevant for any one of these put in. So you can see whatever information is important built into your original design. Then you have the ability to map your data to the graph. What we're talking about here is determining when I import or load data, where is that data going to connect to? Is it to an edge? Is it to a vertice or a node? What is it connecting to? Is it providing some information to multiple locations? And then you'll be able to see it. Because this is a demo, you can't see the right screen, which is basically dragging and connecting the lines between the different lines of data that exist, or the tables that exist in the data you're feeding in, to your different vertices or your different edges, your nodes and your connectors, okay? From there, we can go into loading the data. When we load the data, it's a very simple process. You'll notice this little start button up here. So once I've connected all of my data and done my data mapping, all I have to do is click the start button and it will automatically load all of this data. You see the finished symbols up here. I've already preloaded all of this data. So all of it is already connected into it. You can see over here what kind of data we have. So from IPs to devices to alerts to resource information, all of the different data that exists. And then I have the ability to explore the graph. So I can start off by saying, okay, just show me all the IPs that exist out there. So when I pick an IP, I can drill down on that and see additional information. Okay, so this particular event has an IP address that's connected to it. I can dig into that event and see more information out here. I can see users connected. I can see resources involved. I can see devices connected, all this information. And it's going to start feeding that data out and getting additional information as I expand. So I can see all the different stuff that's coming out of that particular IP address. I can go to all of the different items. If I back up a little bit here and say, instead of just showing me IPs, show me the vertices for all the different types of information. So I can choose the level of detail I want to see right away. I can see my alerts. So I can drill into those alerts and see what kind of alert types there are. So whatever those types are, it's a server connected alert. I can see the different resources that were involved in that particular item, the user events that were coming to that affected that alert, that caused that through that server. So I can dig into this information and follow it through my environment very, very easily. From a query perspective, I've got the ability to really dig in and look for suspicious IP detection. So it's simple. You can see the information that exists in here. I have the ability to see different IP addresses. I can see banned IPs. I can see banned users, whatever I'm looking for. And then I can choose to go in and dig through that information. So if I go back over to my exploring the graph and I see a particular IP address, I can go after that IP address. So if I go back to my queries, I can say, well, suspicious IP detection. I can look at that IP and see the verdict's ID. So let's go to 242.4.237.2, one of my IP addresses, and I run my query. And it's going to show me over here the shortest path to that banned IP. I can see it both in JSON results as well as graph results if I want. I can view the schema to see how it's going to pull it together. So I can dig into whatever level of information I need to or want to for this particular query. Each one of the queries that I have the ability to run them and then see that information. I can see it in graph format. I can see it in JSON format. So I can see all the details about those IP addresses, the services, the edges, anything that's necessary to dig into that information. So as you can see, graph technology can easily help you improve on your cybersecurity status, on the maturity level of your security stack, by taking all of those disparate tools, bringing all that information together from your SIM, from all of your individual tools, feeding into one graph database, and give you the capability to quickly jump in and identify a threat and then push a response or some type of information over to your SOAR or other solution that you choose, and then have a response for it. So with that, what I'm going to do is I'm going to jump back into our slide deck, and we're going to open it up for Q&A.
David, we have another question coming through. It says, in use case and expertise slide, you've mentioned about customer 360. What does that mean?
So customer 360 is an opportunity for you to get a better understanding of the customer. So besides just cybersecurity, when we think about it from the different use cases that exist out there, everything from credit card fraud and so on, we can also do something called customer 360, which allows you to identify a customer and then identify their buying habits or buying patterns. We can look at their user activity, if they're going to a website and using it on a regular basis, if they're recommending friends, if they're going out there and you see a user that is part of a community of people that purchase from a particular region for you. If you're a multinational company, is this person buying online? Are they going into the store? And see where that user's activity is. And it allows you to do things like proactive recommendations. You can do referrals. You can do a customer 360 in the healthcare arena, where a particular patient with a particular case history may be better recommended based on a certain doctor's expertise or capabilities, and you can refer those patients over to the proper doctor more quickly. So there's a lot of different use cases that fit for customer 360. Does that answer your question?
Yes, I think that answers their question. We actually have another one that came through.
Okay.
From a participant. I'd be curious to know more about data sources you're tapping into and how you're pulling information in from them.
So the data sources that we can get is any system that has an API that allows us to connect and pull that data in. We can accept a push, as well as we have the ability to script in a pull. So we can pull data from your systems. You can send data to us however is appropriate. We can also do it through mass export. We have customers that have given us exports that are basically CSV exports that we can do a manual import with. We also have things like Kafka for streaming the data in. that allows you to have real-time data feeds coming in on a regular basis. So there's a lot of different ways that we can get the data in, and really the sources can be pretty much any data source that you have, whether it's a security system, whether it's a database environment, a website environment, whatever the case is, where you're collecting and storing data. If it's a data lake, if you have some type of SIM solution out there that you're storing all this log data in, you want to review it from there, we can pull that data into our system through one of the sources that I mentioned.
David, we have a follow-up to that. Yes, but do we have any other algorithms to identify the customer behavior? Any particular reason to prioritize graph? How can graph create more value?
Well, graph can create more value by allowing you to better understand your customers. So the response question was kind of related to the customer 360. So how do I identify what a customer capability is or what they're doing and so on? We have the ability to better understand by building the relationships inside of the database, as you see in the picture on the screen here, by building those lines in between users, groups of users, departments, buying patterns, locations, things of that nature. We allow you to go out and better understand what a user's habits are. By understanding the habits, we have the ability to provide recommendations that are a little more proactive. So the value that we're giving you is the ability to take the information on everything from your supply chain to your users to cybersecurity to multiple different areas. We give you the capability to understand patterns of activity. We'll help you understand where those users are focused so that we can start helping you recommend new services, new products, new activity, or potentially identify from a cybersecurity perspective, identify threats that are happening inside of your environment and so on.
David, looks like we have a couple more. One participant would like to know how graph databases can be connected to data systems if it has an authentication layer.
So as with anything with your API, you have the ability to connect to secured systems as long as you can do the key pairing that's necessary. So if you're using TLS or SSL and you're doing the key pairing, we can work with you from that perspective through the API. We can also set it up to do transfer of data. It depends on your system, obviously. And the deployment of our environment can be in the cloud. So when I say in the cloud, it can be Azure, AWS, GCP, it can be private cloud. And depending on the deployment method, it can also be an on-prem if you choose. Depending on the deployment method as to what we have to go through to be able to connect to your secured systems. So we obviously will work with you through your deployment to ensure that your security requirements are met and that we're doing the proper trade of information to be able to share the data out of those systems into the graph.
Thank you for that. One final question. Are there already pre-built integrations with some of the key cyber players out there like Proofpoint and I think it's Attivo Networks?
So Attivo, more of a deception type solution, Proofpoint, a little bit of both. So their network and some of their other functions and focuses out there, but are there integrations built with them? No, we don't have them today. We're in the process of working with SIM vendors first to get those data feeds. But I do know, having come from the cybersecurity world, I know Attivo pretty well, and I know Proofpoint pretty well. I can tell you their APIs are very, very solid. So they've got the ability to export data and push it. So from that perspective, we don't have to do a pull. We can do a receipt from them pushing. And when they push the data to us, we can pull it in through our API. It's just an API data mapping exercise that we have to go through with you. So it's no different taking the data from Proofpoint and pushing it into a SIM. We can take the data directly from Proofpoint and push it into a graph database. And as far as Attivo goes, the same thing. Attivo has a very good API And it's similar to pushing into a SIM. What they're going to do is they're going to do data mapping between the two APIs to make sure that the data is landing properly. We're identifying the alerts, we're identifying the IPs, the sources, and all of that information, and making sure that it's properly connected, and then pulling it into the graph for an analysis and review.
Awesome. Thank you for that, David. If anyone has any additional questions, we still have a few more moments. Please feel free to put them in the chat or the Q&A. And David, while we're waiting, any final thoughts for you? Anything you'd like to share with the audience that has popped into your head as you were given the presentation?
Well, the one thing that I'll mention is you have the ability to get started for free. So we have something called Test Drive. Test Drive is something we call starter kits that allow you to test our software and play with it. We have a cybersecurity starter kit. We have starter kits for everything from customer 360 to cyber crimes or dealing with supply chain. So we can help you with any one of these. We'd love to work with you to let your team test it out and play with it and see what kind of response we can get out of the different systems. To give you an example of some of the sizes of our test environments that exist out there, to show that, you know, we're showing the real capability. If we go to our anti-fraud one, there's over 1.1 billion vertices or nodes, 4.4 billion edges. There's over 800 million transactions, 80 million users that exist out there with over 80 million payment systems. So all of that information built into a single graph database, and we're able to give you back response time that is literally sub-second. So we'd love to have you play with it. There's a lot of different opportunities out there for you to take a look. It's both on our website as well as contacting our sales team, and we can help you set this up and determine really what are the use cases that you're most focused on, and we'll work with you to utilize the tools.
Oh, we've got another question. Can we explore probabilistic matching functionality in TigerGraph to get probable match for person or an organization?
Yes, we can. So through the query building with G-SQL, we have the ability to do that probability matching. So it's basically a pattern match that we're going to follow. And that's one of the key functions within TigerGraph that we offer, is the ability to do that pattern matching to help you do that probability matching of users or systems.
Awesome, thank you. It looks like that was our final question. Any final thoughts, or how would you like to wrap it up, David?
Well, folks, I appreciate you taking the time and joining us today. We'd love to spend some time with you and kind of go through some of our solutions one-on-one. So please reach out to us, let us know. We're happy to show you what we can do for you, and we look forward to working with each of you in the future.
Well, thank you, David. I appreciate you teaching us about the cybersecurity world, and your presentation was excellent. Thank you so much.
Thanks, everybody.